good instead of yours, right? So a lot of times you may think that when the price goes up, everybody's going to leave, right? But nah. Potentially. So the idea, though, is then, so what? If you raise the price enough, if people leave, who cares, right? Well, the reason why is this. What is price times quantity? So in other words, if you have, say, you have a convenience store, and you're selling candy bars, and you sell candy bars for $1 a candy bar, and you sell 20 candy. What is $1 times the 20 candy bars that you sold? $20. That's $20. That's also the amount of money that's sitting in your till, right?
Plus 5.5% per bar for sales tax.
Of course, because we never take the chance away from charging the customer more if they will be willing to pay it, right? So the idea is that price times quantity, what that is revenue. Right? That's why you care. Because one of the number one things that you care about in business is making money. And so you want to make sure that you make money. Well, what that means, though, is that we need to have some numbers. We need to have numbers to be able to determine if our money has gone up or our money has gone down. So we're going to have to get to some numbers. Well, yay. Exactly. Therefore, we need a little math. So instead of giving this rather cryptic definition of how responsive is demand to a price change, which, sounds not so bad necessarily, but what you really are trying to do is measure what is the percentage change in quantity versus a percentage change in price. So the math definition is, what is the percentage change in quantity, and let me put a little quotes in here and realize that it's quantity demanded. We're really worrying about demand here, folks, more than we're worrying about supply. What is the percentage change in quantity per percentage change in price? That's the math way of saying how responsive is demand to a price change. How much is quantity going to fall when we raise the price? And the key here is that you don't measure it in hard numbers, right? You're not going to say that if I raise the price of my candy bars to $1.50, that I went from 20 down to 10. That's not how you actually do it. The way a businesses will do it is they'll always do it using percentages. Percentages drive the business world, okay? Because hard numbers are too difficult to come by. It's too tough to say, well, if I lowered the price by 30%, if I lowered the price by a certain dollar amount and the quantity went up, because are you going to raise it by 30 cents everywhere? Not if your convenience store is spread throughout the country, right? Prices in New York are higher than prices are here, are higher than prices in LA, so it may be a 70-cent change in LA, a 20-cent change here, and an 80-cent change in New York. So you don't want to use the hard numbers, you want to use the percentages, all right? Now, if you're going to have a math definition, you need a math formula. Oh, yes. Yeah. This is the really good stuff, right? All right, the best part about this is that the math formula is a direct translation of the math definition, which should make you at least feel a little happy.
It's going to look like algebra.
Maybe, but maybe not. All right? So we want to talk about percentages. When you write the word percentage, what do you normally write as a mathematician?
Symbol.
You write the little percent symbol, right? Yeah. All right. So the math formula is going to start with a percentage sign. Now, maybe some of you know this, some of you may not. When a mathematician sees the word change, what does a mathematician write, symbol-wise? Not quite. No one of you have seen this one before? All right, well, the way a mathematician writes change is they put down a triangle in there. A triangle to a mathematician means the word change. All right? I actually had a student who knew that when I taught this on Monday night. I was like, really? Wow! And, you take the little things where you can. All right. In quantity, what have we been using for quantity?
Q.
Bam. Percentage change in quantity. There it is. Now, per divided by. All right. I knew there'd be some mathy people out there. Sorry, Kyle. And then we get to the word percentage again, right? Percent. And I'm getting to the word change again. What am I going to write? Triangle. And then B.
What will future Americans say about ancient Americans when these symbols are applied?
So the percentage change in quantity divided by the percentage change in price, that is the elasticity. So guess what we call elasticity? E. Hey, what do you know?
The sum of all things.
All right, so now we have a math formula. Now the question is, when are we going to start to see changes in our revenue, right? So revenue is what we care about. We don't really give a crap what the price is. And in fact, we really don't care how much quantity we sell either. What we really want is to have the most possible money sitting in our till at the end of the day. All right, that's one way that a business can work, is all they care about is looking at the money coming in. Now, you guys know that that's not the way it works, but for today, let's assume that's what we're doing. All we want to do, maximize dollars in the till. All right? So, when, say we make a 5% change in price. So if our candy bars were $1, all of a sudden we raised it to $1.05. All right? If we raised the price by 5% and the quantity took a header because of it, suppose the quantity that we sold dropped by 10%. All right? So at that point, price and quantity, when the percentage of quantity changing is greater than the percentage change in price, and in other words, more people left because of what you raised the price by, your revenue decreases. That's the law of percentages, all right? Now, I could spend some time proving that to you, but I don't want this to be a math class, and I don't want you to kill me. Well, it would just be 2. When you take a percent divided by a percent, the 2% essentially cancel, and you have what's known as a unitless number. All right? So the key here is that when quantity change is greater than the price change, your dollars go down. All right? In other words, it sucks. Now, the nice thing about this is that what do you know about fractions where the number on top is greater than the number on bottom? What? It's improper. That's exactly right. And what does that mean about the number? That means that it's more than... It's more than 1, right? Anytime the top number is bigger than the bottom number, this number as a fraction has to be more than 1, right? So one of the magic numbers in elasticity is 1. Now, does everybody know what this symbol means? Oh, good. See, you are math nerds. Excellent. All right. So when E is greater than 1, or change in quantity is greater than a percentage change in price, we lose revenue when we raise the price. Because the change in the quantity kicks us in the pants. Right? So sometimes raising the price is bad. All right? Now, let's assume it works the other way. All right? Now, most goods that you think about are elastic. All right? This is what's called elastic. The way I like to describe elastic and inelastic types of demand is to use the underwear example. Have you guys ever heard the underwear example? Okay. You know when you buy a nice, fresh pair of underwear, you put it on the first time, and you're checking it out to make sure that it's new, right? So you pull the elastic on the waistband and you let it go. What happens? Smack, right? So you pull it out. You don't waste a whole lot of energy pulling it out. But when you let go, smack, right? It smacks you coming back real hard. That's elastic demand. When you change the price, when you raise the price just a little bit, 1, 2, 3%, everybody else looks out there and says, smack, right? They're snacking back. They're saying, no, we don't like that. I'm going to quit buying your good. So the amount of people who quit buying your good is higher than the amount of the percentage change in your price. That's elastic. And it's because when you pull the underwear, it snaps you and it hurts more, right? Now, when you have inelastic underwear, this is when you've had the underwear for a couple of years, maybe 5 or 6, 7, 8. Well, you washed it once or twice, right? And when you go to pull out that elastic, you kind of let go and it sort of waffles back. Maybe it doesn't quite get there as fast. It kind of goes, gives you a little tap, right? When it's inelastic, when your underwear doesn't smack you coming back, that's when you raise the price. Maybe you raise the price by 5%, but instead of all of your people saying, oh, that price rise was terrible, they say, oh, yeah, we'll buy less, but not as much less as the price change, right? So if you raise the price by 5%, maybe the quantity only changes by 2, all right? Remember, though, anytime you raise the price, quantity is going to go down a little. It has to, right? But if it doesn't go down as much as in a percentage, then you win, all right? So when we get to the other side of the coin, when E is less than 1, or the percentage change in quantity is less than the percentage change in price, here we gain revenue when we raise the price. That's inelastic. So what I like to say is this is the new pair of underwear, and the inelastic stuff, that's the 10-year-old underwear.
So you think new underwear is bad?
That's exactly right? The first time you put them on, they're just a little too tight. You're just like, it would be nice if these were a little bit more comfortable. You need to wash them 4 or 5 times before they really become decent. Again, it's not necessarily good or bad. Now, think of it in terms of this, right? Right now, we're only thinking, right? What if we went the other way? Think about this elastic demand, right? We're selling candy bars for $1. Pretty much everybody else around the city is selling candy bars for $1 too, right? So what happens if you decide to lower your price to, say, 80 cents? All of a sudden, what's going to happen to your quantity? When it's elastic, everybody's going to say, well, the candy bar that I bought at Marshall's convenience store is no different than the candy bar I bought at Naomi's. So when hers is $1, mine's 80 cents, as long as we're relatively close to each other store-wise, what are they going to do? Come over to me, right? So when you have elastic demand, what you really want to do to increase your revenue, drop the price, stab your competition in the back, and steal market share. When you're inelastic, when people are going to buy your good no matter what when you raise the price, can you think of a good that's like that? Gas? Yeah. I mean, when they raise the price in gas, do you buy less gas? You do. You do your best, but you can't, right? Eventually you're going to have to pay for it, right? When they raise the price in gas, it's not that you're trying to stab people in the back. You're not trying to stab your competition. When you raise the price in gas, you're saying, oh, too bad, the consumer's screwed. Anyways, I can raise the price and I'll make more money. Yippee. They got to buy it, right? Inelastic demand is basically you got to buy it. Or at least in some fashion, you need this good, right? Your need is greater. Or there are no substitutes, right? What can you substitute gasoline for? What can you use to substitute for it?
Diesel, but you have to have the right equipment for it.
I mean, there's not a whole lot of substitutes, right? So this is sort of leading us to why certain things are elastic, why certain things are inelastic, right?
So if you're a fat cat with these underwear, you got enough money and you have a product that they can't do without, you can pull that band all you want to.
Yeah, because you're...
about if it snaps, if it doesn't.
I mean, it'll snap, but remember, you're the fat cat, right? So you're big, right? You can't pull that underwear very far anyway. So you're only pulling it a little bit, and it comes back. Oh, yeah, it hurt a little bit, but I don't got to worry about it.
I'm going to make money anyway.
That's exactly right. I love the underwear example. All right, so if we have to worry about greater than 1 and less than 1, what might we worry about?
Equal to.
Hey, good idea. So that will then take into account all possible cases that we have, right? That'll cover the gamut. When e is equal to 1, what do we know about fractions that are 1?
They're a whole number.
Then, well, they're the same. They have to be the same number, right? If we change the price by 5%, the quantity had to change by 5%. They have to be the same number in order for e to be 1. And when your percentage change in quantity and your percentage change in price are the same, your total revenue doesn't change, right? So if you raise the price, yeah, you're going to sell less, but the amount that you sell less is going to be made up by exactly how much you raise the price, all right? So here, changing price does not change revenue, ever. Doesn't matter, all right? And this is elastic. This is inelastic. We call this, and I apologize to those of you in the back, this is known as unitary. Unitary, of course, since e is equal to 1, another word for 1 is, of course, unit, so it is unitary. Good stuff, right, David? All right, so this is the concept behind it. Now, the cool thing about it is that we can actually show this is true with numbers. Look, come on, you guys want to talk about the economy? You've got to talk about numbers if you're going to talk about the economy, right? I mean,
It's about the economy.
All right, so we're talking about demand, so what we need is a demand schedule. In other words, based on the price, how much are you going to buy? And I'm going to make it a nice, straightforward example to begin with, so the numbers aren't painful, so you guys can't groan about the math. True. All right, so for simplicity's sake, let's say that when the price is 1, I will buy four things, whatever they are. When they raise the price to $2, I will say, I'm only going to buy 3 of them. When they raise the price to $3, I'm going to say, I'm going to buy 2 of them. And when they raise the price to $4, I'm going to say, I'm only going to buy 1 of them. So no numbers larger than 4, no numbers smaller than 1, no fractions, nice, real basic numbers. All right. So now I start asking you, okay, realize that elasticity is measured between prices. All right? So the first key here is realizing that there are 3 measures of elasticity in this demand schedule. Even though there's 4 rows, there's only 3 because you compare these 2, you compare these 2, and you compare those 2. All right? So please don't tell me that at $3 the elasticity is something. That means nothing. You need to tell me that between 2 and 3 the elasticity is something. All right? So when we start talking about price elasticity, we're always comparing 2 prices. All right, now, when we calculate the percentage change in quantity as an economist, we are going to use what's known as the average change in percentage quantity. All right? So it's going to look like a slightly different formula for percentage change if you happen to know what it is. Okay? So bear with me to some degree. This is just how you calculate mathematically the average percentage change. It's just a formula, don't sweat it. When you get formulas, you guys know that eventually you're going to get numbers and you're going to plug them into the formula. That's going to be our goal here. So if this is how we calculate the percentage change in quantity, guess how we're going to calculate the percentage change in price? How is this going to look any different when we change the Q to a P? It's going to be P's instead of Q's. Deep, eh? And now, what do those little 1s and 2s mean? The second price and the second quantity. Very deep, right? And the cool thing about this is that whichever price you pick to be 1 and whichever price you pick to be 2, you can switch the order and the answer will be the same. All right? So, let's use these 2 points to start with. Let's figure out the elasticity between these 2 points. All right. So, E is equal to this percentage change in price. And it's this formula. All right, so let's do the top first. What is the, we're going to pick this one to be first, this one to be second. Be careful, we're starting with quantity. Exactly. So we're taking the second quantity of 3 and the first quantity of 4. And the nice part about economists is that they don't care about negative signs, so whenever you get a negative sign, just throw it away. It makes me absolutely want to vomit because I'm a mathematician, but for you guys, hopefully that'll make you feel a little better, right? So whenever you see a negative sign or a minus sign in this thing, just kind of say, yeah. The idea here is that what you do is actually calculate the absolute value of this. So if you're a mathematician and you want a real reason for this, it's called absolute value. But in essence, what it means is throw all minus signs away. Okay? So Q2 minus Q1, we say 3 minus 4 over 3 plus 4. Okay, now that's the top half of our fraction. So unfortunately, we're getting fractions over fractions, which I know will make you groan, but that's okay. Now do the same thing, except now do it with the prices instead of the quantities. So our second price, 2 minus 1. And again, these are not hard numbers, so you should be able to do all of this subtraction and addition yourself, right? It's just potentially that very last step that gets scary, okay? Because what's 3 minus 4? 1 to an economist, right? Again, I will cringe while I say it, but it's okay. This is 1. What's 3 plus 4? 7. What's 2 minus 1? 1. What's 2 plus 1? 3. Okay, now here comes the hard part, if you will. You actually have to divide some fractions. All right. For those of you who haven't had any of my math classes, hopefully they taught you this and you know it. All right, when you divide fractions, the way you do it is you flip and multiply. This is 1/7 times 3 over 1. Notice what I flipped. Realize, folks, I'm not going to ask you to do this ever. You will have to do it once on the homework, and then you will never do it ever again. All right, so I will not ask you to divide fractions in this class. All right? So you'll do it once, or you do it a few times on the homework, but that's it. All right, and when you do it on the homework, I advise you to pull out a calculator and punch into your calculator 1/7 divided by 1/3. You got a calculator, do it. All right. This is 3/7. Now, what do we care about when it comes to elasticity? What's the magic number in elasticity? 1. Is this number more than 1 or less than 1? Less than 1. So what do we say about the elasticity between these 2 points? It's less than 1, so it is inelastic.
What does that work out to in a dollar amount? Or does that not matter at all?
Well, let's look at it. What's our total revenue if we were selling these items? How much money would we make if we set the price to $1? How'd you get that?
Because price times quantity.
Price times quantity, and you guys can do 1 times 4 in your head. Total revenue here? $6. What did I tell you about inelastic demand? We gain revenue when we raise the price. We raised the price from $1 to $2. What happened to the total revenue? We gained revenue. This is a way for you to determine elasticity without doing any of that. All right? So if you want to figure out what the elasticity is between 2 points, calculate the total revenue and then say, when the price went up, what happened to total revenue? If it went up, then it's inelastic. If it goes down, it's elastic. If it stays the same, it's unitary.
So then between $2 and $3 would be unitary, and between $3 and $4 would be elastic.
So now, without having to do any of our baloney stuff, sorry about that. What's 3 times 2? $6. What's the change in total revenue between $2 and $3? None. What happens? What are you when you have no change in revenue? Unitary. The elasticity between these 2 points, between our second and third points, is unitary. And we can take it one more step. When we raised the price to $4, what happened to our total revenue? It went down. When total revenue goes down, when we raise the price and total revenue is lost, we switch to elastic. So this, it's a good exercise, but it's unnecessary. Okay? So this is the long way. This is the shortcut way.
Are we going to do the shortcut way?
I would expect you to do the shortcut way. On the tests and quizzes, you will only need to do the shortcut way. I will never on the test ask you to calculate E. Never. All right? So quizzes, tests, you will not do any E. One homework problem, one part of the homework problem is to calculate some E, if you don't mind. Okay? But really, what I care about are these 3 things. That's what I'm going to be asking for on the test. I'm going to say, given this price and this quantity, this price and this quantity, tell me what the elasticity is between the 2 of them. And then you'll pick one of these 3. Or I might make up a 4th one so that there's a 4th. I like to make up words.
It should be unitard because those are elastic.
All right, so.
Don't feed him. Don't feed him.
So this is how I would really like you to do elasticity. So what I'd like you to do one more time, except now I'm just going to give you 2 random prices and quantities. You tell me what the elasticity is. All right, so suppose that when the price is 40 cents, you sell 20 items. And then you change the price to $4, and you sell 25 items. Tell me what the elasticity of demand is for this item between those 2 prices. And again, your answer should just be one word, either unitary, inelastic, or elastic. Does require you to do a little bit of multiplication there. But hopefully you guys know what 4 quarters makes. All right, so what did you guys come up with?
Not that fast. Is anyone really going to know about that? Unitary.
They'd have to be the multiplication of these 2 would have to be the same if it was going to be unitary. Well, it could be. I don't know. I haven't done the multiplication. I can't do that in my head. That's too hard. Inelastic, is that what you guys have all said?
Yeah.
Now, why?
Explain.
Explain. Revenue went up. So up here, how much was the revenue? $450, 20 items. How much did we make? $90. Cool. $4 here times 25, 100. So the quantity or the total revenue went up, therefore it's inelastic. Wait a second. Stop right there. Which direction did the price go when you did that?
Price went down.
The price went down from 450 to 4. You need to look at it from the other direction. The price went from $4 to 4. We're going to go up.
Not the total revenue.
What happened to the total revenue when you went from 4 to 450? It went from 100 down to 90. Yoink. This is elastic.
Well, you should trick us like that.
I'm just pointing out to you how the wording of the problems is going to be. I will almost always give you the higher price first and then the lower price so that you have to think as opposed to just do, right? I don't like classes where you just do. I like classes where you think.
So basically, anytime you see something like that, you need to always put it in price order.
You got it. You in your brain, when you make this little table, make the lower price first, the higher price second, so that you can say what happened to total revenue. But you have to be clever enough to do that. All right? And I guarantee you that half of you are going to fall for that trick when I put it on the quiz.
A true mathematician wouldn't trick us like that.
Oh, yes, he would.
How many times out of 100?
True mathematicians love it like
You
that.
said a cruel one would.
All right. So we can deal with elastic and inelastic. Now, the question I have for you now is what kinds of goods have elastic demand and what kind of goods have inelastic demand?
Spanx.
I mean, you worry about them. So what stick?
They're an undergarment called Spanx. Why, I'm not sure.
Meaning where when you raise the price, the percentage change in quantity will be higher and your total revenue will go down. Wants. Okay, so tell me one of your favorite wants. Pepsi. Okay. Pepsi is an elastic demanded good. And again, why is it elastic? Well, need is definitely a piece of it, right? Or if Pepsi raises its price, what might you do?
Switch to Coke.
You might switch to Coke, or you may buy RC, or you may buy, cola. And for some people, Pepsi is not elastic, it's inelastic. Where if the only soda you drink is Pepsi,
That's the norm for you then.
yeah, when they raise the price, do you buy something else? No. But what will you do when they raise the price? You'll buy a little bit less. The question is, if based on the percentage, how much does your percentage drop go down? Right? Again, that's the same sort of a concept. All right, so what might be inelastic? Gas is the number one example. Potentially, right, Pepsi. Medication, there's a good one. If you consider food generically, right, not just a specific type of food, but food in general, right? I mean, what happens if you don't buy food?
You die.
You're going to die. What else, if you don't buy, are you going to die from? Water, right?
Utilities, well, your water, but light power.
Power and electricity, that's exactly right. I mean, those are the sorts of things that they raise the price on it. Or, I mean, you'll try and shut your lights off more, but are you going to really? Probably not, right?
My husband screams at me if I don't.
True, but if the price of electricity went way down, your husband would probably scream at you a lot less. Right? He'd be like, oh yeah, that's going to cost me a nickel. Who cares, right? But if it's going to cost him a dime, then he's going to get pissed. All right, so now the question is, what characteristics describe things that are elastic versus things that are inelastic? Characteristics of elasticity. All right, now I'm going to give you the number one first, because it's the biggest one, right? The reason that Pepsi is generally considered elastic is because there are lots of other types of soda that are like Pepsi. Are there lots of other things that are like gas? Not really. Are there lots of other things that are medication for the illness that you have? I mean, maybe, but then those may not work as well, right? Is there lots of other things other than food for you to ingest and survive? No. I mean, not really if you think about it, right? And you may say that I could drink Pepsi instead of water, but what do you got to have to make Pepsi? Water. Darn details, right? So the number one thing that makes something elastic, substitutes exist. If there is a substitute for a good, it will be more elastic. Right? If you can substitute something for it, then it's going to be elastic, right? Like fast food. When McDonald's raises its prices, McDonald's usually experiences a loss in sales because there are lots of substitutes for it, right? And so what McDonald's tries to do is it tries to tell you that you have to have McDonald's, right? That it's a need. You guys were saying this already. So the less you need something, the more elastic it is. Now, I'm giving to you these all in terms of elastic. Please realize that the opposite makes it more inelastic, all right? So the less you need it, the more elastic it is. The more you'll say when the price goes up, screw it, I don't need this anymore. Think of it in terms of the elastic side. When the price goes, things that you do need, they are more inelastic. You got to have them, so you'll pay the higher price. That's life. Time. The more time you have to deal with the price change, the more elastic you are. In other words, if gas prices all of a sudden hop up to $4 a gallon and stay there for 2 years, what are you and I going to start doing as we start having to deal with gas prices at $4 a gallon for 2 straight years? We're going to start to learn how to ride our bikes to work. We're going to start buying electric cars. We're going to start buying... Essentially, we're going to find substitutes for gas. We're going to say, I can use electricity instead of gas to move my car. But it takes time, right? So the more time that the price of a good is up, the more likely you are to eventually develop a substitute, all right? And then the last one that I like to talk about, and this one I just like to talk about because I like to say the word, is the breadth of definition. And that's one that ties into the food side of things. If you narrow your focus, of your definition, it becomes more and more elastic. Right? So when you say food, that's very broad. It has breadth, if you will. Those things, food, are more inelastic. As you start to narrow it down and you say meat, well, now meat is starting to have substitutes, right? You could eat nuts, you could eat tofu. You could eat what other meat substitutes there are. And if you narrow it down even more and say beef, now it's even more elastic, right? The narrower we get, the more elastic, the more we can substitute. Because if you don't want to eat beef, you can eat pork, you can eat chicken, you can eat fish. Again, you could still eat tofu. Right? And as you go even narrower, you could say Kobe beef, right? Maybe I'm only going to buy the kind of beef that's hand-fed and gets 2 beers a week, and there's a masseuse who massages the cow every night. You guys have heard about Kobe beef right out in Japan? They treat the cows better than the people, right? I mean, they get their nails done every week. Because a happy Kobe beef cow tastes better after you... Well, whatever, let's not go down that road. But you get the idea. These are the sorts of things that drive elasticity in an actual product, all right? So price elasticity is where you have numbers. When you take off the price in front of it, then you're just talking about how elastic is a good in general. That's when you get into these characteristics. And one last thing before we call it a day. This is the last thing. You got to have some graphs, right? I mean, you can't have a class in my... I know, you can flip the page over, though. That's the nice thing. Remember that we're talking about, this here is a price quantity schedule. It's also a demand schedule. Therefore, this describes demand. So I should be drawing some demand curves about elasticity. All right? So this is a very steep demand curve. All right? Remember that this is price and quantity. Imagine that my price is right here, and I say, okay, I am Mobil Oil, and I say, here's the price of gas. It's like $3.50 a gallon, whatever. I'm going to raise the price up to $3.60 a gallon. It's still a demand curve, so we're going to experience a loss in demand, right? Quantity is going to go down. But how much does it go down? Well, when the graph is nice and steep, here's the change in price. Here's the change in quantity. Which one's bigger? Price. Right? When the price changes more than the quantity, what type of a good do we have? Inelastic. This graph of a line is inelastic. So when you graph demand and you know that the product is more inelastic, you know that the demand is a steeper line. Because you know that changes in price do not make big changes in quantity. Now, if we flip the coin around, guess what a elastic demand is going to look like? It's going to be nice and shallow, right? It's going to be almost flat. Right, here's our demand for stuff that is elastic. And the reason why here is that if this is my price, I'm selling that much of my good. When I raise my price just a wee tiny little bit, what happens to the quantity? Oops. We get shot in the foot. All right? So, what I want to leave you with, so that you have to think about it a little bit, what might you call a demand line that's absolutely flat, or perhaps perfectly flat, or perhaps perfectly steep? Unitary, well, don't worry about the graph of unitary. That one, it's a logarithmic graph, which I don't want to go into. So what happens when it's perfectly flat? That's actually pretty good. What we call it economically is that this is perfectly elastic, right? So the flatter you are, the more elastic you are, and if you actually get to flat, you are perfectly elastic. So guess what we call the one going straight up and down? Hey, see? You guys are mathematicians. So the idea, again, is that when you're flat, you're elastic. As you get steeper and steeper and steeper, you're becoming more inelastic, but you now have some elasticity. At some stage, you make the turn, right? You've gone from being a more elastic line to being a more inelastic line until you rotate all the way to straight up and down, and you have flipped to perfectly inelastic. All right, so homework, chapter 5. Somebody tell me what page it's on. It's like 110 or 115 or something. That's the practice quiz, so 109, right? 109. Okay, so page 109. Numbers, and let me see them really fast to make sure I don't choose the wrong ones. 4, 6, and 8. Do those look okay? Oh, yeah. 4, 6, and 8. For number 4, please do calculate the E coefficient at least once. Okay? At least once. You're supposed to do it 4 times, but I'll be happy with just once.
In what number?
Number 4.
Are you obsessive compulsive? The reason I ask is you never choose odd numbers for us to do.
Did you look in the back of the book yet?
No.
It's all odd.
The odds are all have answers in the back.
Oh, I didn't know that.
So I am obsessive compulsive, but there's a reason.
All right.